As you know from the previous section, we gave the definition of the derivative, and then we said that using this definition to take the derivative of any given function is so hard, since it has the limit, right? And using a limit has a lot of problems, and for the complex type of functions, doing this calculation is going to be so difficult for us. That's why, okay, we're going to need the simpler calculation rules. In this section, we're going to give those rules without proof. Of course, if you would like to see the proof, okay, you need to use this definition again, since there is nothing around, okay, except this definition. This definition will help us also deriving all those rules, okay, and then it is going to help us to give the proofs as well. But it also helps us, okay, taking the derivative of any given function. So let me give you the basic derivative rules. So the first rule is taking the derivative of constant function. If you have the constant function, the derivative of this function is 0, right? You can just use the limit definition. If you put the constant on the top, k minus k, which is 0, as you see. So it is easy to prove it. The second one, the derivative of the function and then multiplied by a constant. So I can take the derivative in this way. There's another notation. Look at that. So in this case, you can just keep the k outside, and you can just take the derivative of function and then multiply by the function later, derivative of the function later. The third rule is the addition or the subtraction rule. If you have the two functions, you add or either you add or subtract them, and then if you would like to take the derivative, you can take their derivative separately, and you can add them or subtract them later. And then the fourth rule, okay, which is gonna be, okay, most important rule for this section, since it's gonna help us a lot, this is called the power rule. Power rule, okay. Power rule is about, okay, taking the derivative of this type of function. As you see, it is a power function. You have a number on the top of x. If you would like to take the derivative of this is equal n times x to the n minus 1. What you do here, you need to bring the n down, and then you need to decrease the n by 1. That's what we call the power rule. Now, with these four rules, you will see, okay, we will be able to solve a lot of problem, and then also we're going to apply this, okay, in the real world problem. So let me give you a couple examples. F of x, okay, let's say f of x is equal x to the 5. So as you see, this is in the form, right, x to the n, so I can definitely use the power rule, right? I'm going to look at that power rule to take the derivative. So what it says, power rule, bring this down. So I'm just going to bring the 5 down. And then please decrease the number on top, which is going to be equal to 4. That's it. Second example, maybe that would be equal, f of x is equal 7. This is a constant, so the derivative is going to be just 0, okay? That's it. Another example, if f of x is equal 7x to the 10 minus 5x squared plus 7. As you see here, I have three different functions. You can see in that way, right? I can split them up, and then I can take their derivative, okay, separately. So my question is, as you know, the derivative of this expression. But what I will do, I will use the sum derivative. So I can split them up, right? I can separate them, and then I can take their derivative later. Okay, as you see, I have three different expressions. I can apply this rule, addition for the derivative. And what is the derivative of this first part? First of all, as you see, I have a constant. I can take this out first, right? Without modifying it. And then now here I'm going to use the power rule. Power rule says bring this down, right, bring the power down, and then x to the 9 minus, so 5 will be outside, right, bring this down, and then, right, decrease the 2 by 1, which is going to be 2x, and then the derivative of constant you have here, which is 0. So if I arrange my terms, 7 times 10, which is going to be 70, x to the 9 minus, that was the multiplication, 10x. I hope you saw how I combine all those rules, right? The power rule, constant derivative, okay, derivative of the sum of the two functions or the subtraction of the two functions. As you see, to take the derivative of, right, the just one function, I needed to combine all those rules. So basically, when you apply these derivative rules for the polynomial type of functions or the power type of functions, right, it is good to have all these rules, since it helps us, okay, to apply these rules. But we will need more rules, okay, for the other type of functions. We will learn, okay, later in the other sections. So now I would like to give you a couple of real-world examples so that, okay, how we can interpret these derivatives, and then how we can apply these rules for the derivative. Let's look at this example, which is about, right, blood sugar level, which is given by this function. So if you like to write the effect of the insulin on the blood sugar, so it asks you, find the blood sugar level after the following number of units of insulin are injected. So if you don't have any injection, right, this is gonna be your blood sugar level at the beginning. But after, right, the 25 units of insulin injection, your blood sugar level, right, will decrease, of course. So that's why they inject the insulin for their blood sugar. But what is the rate of change, right? So do you need to keep taking the insulin injection, or at what level, right, you can keep taking it? If you look at, right, the rate of change, of course you need to deal with, right, the derivative of function, which is, it is so easy to take it. As you see, you can just, right, apply the power rule here, which is going to be equal negative 0.4x, since you dropped, right, the 2 here, multiplied by 0.2, and then this is the constant derivative is going to be 0, so there's no effect there. So after taking, right, the 10 unit of insulin, right, the rate of change will be, right, the negative 4 unit decrement for each unit you take. So, but if you take, right, if you keep taking it, the rate of change after taking, right, the 25 units of insulin, right, the rate of change, right, will be this one. So you can decrease 10 units for each injection after 25 units. That's how we can interpret of, okay, these results. As you see, right, the derivative helps us to understand the nature of the blood sugar rate of change. Second example is about the revenue. So you have the cost function, and then you have the revenue function. As you know, right, the profit can be given revenue minus cost. We have seen it before. So question here is to find the marginal cost and the marginal revenue. Marginal means, as you know, the rate of change. You just need to take the derivative. If you take the derivative of marginal cost function, it's going to be 2, right? Since it's a polynomial, just use the power rule. And the marginal revenue, you need to, right, to take the revenue function derivative. It is also, right, the polynomial, so you can just apply the power rule to figure out what the marginal revenue is. Okay, after finding out in part C, it asks you, right, the marginal profit. What is the marginal profit? So you just need to take the derivative of the profit function. What is the profit function? We said that revenue minus cost, so the derivative could be, right, the difference of these marginal function formula. So marginal profit then is going to be equal 6 minus 2x over 1000 minus 2. I can just take the difference, which is going to be equal 4 minus 2x 1000. In part D, it asks you what value of x makes marginal profit equal 0. So I need to make this equal 0, 0, which is equal 4 minus 2x 1000. I need to calculate this value. So x is going to be equal here 2000. So if you produce 2000 units of the product, your marginal profit will be 0. But what is your profit at your when your marginal profit is 0? So if you calculate the profit function, not the derivative of it, you just need to take the derivative of those two functions and then plug the x equal 2000 there, which is going to be $4,000. So your marginal profit, it could be 0. That means, your profit doesn't change, at this production level, but still you are making profit, The rate of change means, what is your profit change as you keep producing your products to sell. But you can decide, after, increasing or decreasing the product, how much profit will be affected, by producing at different levels, guys. So in the next section, of course, we are going to have some different rules, since we need to, understand the nature of each function, and then rate of change problem are so important for the real world applications. That's why, we need to know exactly how we can take the derivative of any given function. That's why we are going to need more rules, and then we're going to see how we apply them to the real world problem.